Hello, my name is Chris Harding, and I'm one of the administrators at Beginning OpenFOAM on Facebook. It's a group of beginners helping beginners, and I'm a beginner myself. But today, what we're going to be doing in this tutorial is we're going to be creating a geometry for one square cylinder that's affixed to the bottom surface. And this right here is an article that I found, and if you take a look at the geometry, the specifications, and I included this in the information underneath the video, and the link is there in the title. But I want you to take your time right now, and if you would, if you're going to do this tutorial, is to create this geometry right here according to 10H, 20H on your piece of paper. So I'm going to go ahead and pause the video and give you an opportunity to do that. Okay, hope you actually have the geometry created. And now I want you to think about meshing. And I'm going to pause the video and I want you to think about meshing. How would you mesh that, uh, the geometry of what you just created? How would you mesh it? And while you're thinking about that, I want you to think about the fact that an aspect ratio of 1 is considered to be the best aspect ratio for hexahedral meshes or hexameshes. And so I want you to think about the fact that the aspect ratio is best at 1, and then think about how you would mesh this geometry right here. And I'm going to pause the video so you can do that. Hello. Okay, so I've advanced a little further in the documents, page 53. But as you can see, what they did was they separated and they created a box at the all around the actual a box that surrounds the box on the floor. And the one aspect ratio of 1 means, and what they did in this document, you can read it for yourself, they did a mesh of 80, so 80 lines along here and 80 lines along here, and then they did a mesh of 160. And me personally, when I run this, I plan on running the one at 80 and then possibly the one at 160, because I'm going to compare my results to what I get from this document or what I see from this document. But as you can see, this is how they set up the mesh. Now, I want you to go ahead and I want you to go ahead and draw the lines for your document or your geometry that's like this. Don't put in the numbers yet. We're not going to number it the same way they did. We're going to number it a little differently because we're going to use pointField.H, and pointField.H programmatically is going to allow us to specify fewer points, 1/8 of the total points, and we're going to do the rest of it by programming with a couple simple if functions, or if statements rather. And so go ahead, I'm going to pause this, go ahead and finish out this. Okay, so hopefully you've drawn this out, because this is going to be crucial to the rest of this tutorial. This tutorial is going to be hard to follow without drawing this out, because we're going to get our faces and our blocks from this geometry right here, because we had to create this same geometry in Block Mesh Dictionary and then mesh it. Okay, here's what I want you to do now. Ignore the numbers that you see in this, but I want you to start at the bottom left block where it has 1 in here. I want you to number that 1, and then I want you to number the bottom row as continue numbering it. So you're going to have 2, 3, and 12 is going to be 4. And then I want you to number the top row with a 5, and then it's going to be 6, 7, 8, and the 13 is going to be 9. And then I want you to number the top left 10, and then it's going to be 11, 12, 13, and the the top right corner is going to be 14. So I want you to go ahead and take care of that, and I'm going to pause this, and I want you to number it according to how I just said it. Okay, let's see here. So do you have it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Make sure you have it numbered that way to be able to follow with the rest of this. And it's a good idea to do that because programmatically when we do it, it's going to be going from left to right anyways. So that's the reason why I'm keeping the numbers in a certain order. And you'll have that idea the more you do these programmatically. And this is one of the parts of a series of tutorials. So there's multiple tutorials before this, but most of them are also a person can do just by jumping into the tutorial too. They just have a little bit idea how to do foam clone case, and that's what we're going to go to next. So we got run here, and let's do ls. See here's Pitts Daily, Point Field, and STTP 2020, and that's Dr. Gohill's training. And I am doing additional challenges on top of what Dr. Gohill challenged, but his ultimate challenge was to create all the geometry on your own, and I want to use pointField.H to do that. So I'm teaching myself how to think programmatically and create geometry, or getting better at it anyways. So let me see, let's change this to pointField. And let's see what we have. We have 4 block, 3.2 point and cylinder, and then cavity. The 2 point, we used 2 points and we grew a total of 8 points. So we specified one quarter, and 3 point, we had 3 points, and we in 4 block we created 4 blocks. 3 points we created 2 blocks. 4 block we created 4 blocks in a cavity geometry, so that we can mesh each side, each wall, and the top wall as well. That was moving in the cavity tutorial, the standard cavity tutorial. So we're going to go ahead and we're going to clone, and you can copy it if you don't use foundation versions, but this is a foundation version 7. Foam clone case, 4 block to, we're going to say small block. Okay, so what clone did is just basically it cloned the system to the small block system, constant to constant, and 0 to 0 folder. And so now after we did clone case, we're going to do an ls here, and we see that we have small block created. Let's go ahead and change directory into small block, and we have 0 constant in system. And what's going to be different than this, you can tell that the geometry that you see here with the numbers, this geometry is actually definitely not a cavity tutorial. So we're going to run into errors later on that's going to make us aware of that. And I'm just going to go along so you can follow through and then see those errors. If you want to jump ahead to the end, and that's fine, you can see that I've created it successfully. But it's hard to learn from the end alone. So let me see here. So we're in small block. Let's go ahead and Genie system block mesh. And we're going to specify a total of 1, 2, 3, 4, 5, 6 points. That's all we're going to specify. We're going to grow the rest of these points from those 6 points symmetric, so it's going to be easy to do. So we're going to need 6 points. And our first point is going to be 0, 0, 0. And this is where I'm going to have to do some math. I'll be right back. I got to pause this. And the math I suggest you do is to follow from page 50, I think. And we got to figure out what H is. H is 2 centimeters. So first of all, what we want to do is we want to change Block Mesh Dictionary to centimeters. And that's 100 centimeters in a meter. So it's 0.01 meters in a centimeter. So this will convert it to centimeters. Let's save that. Now I want you to realize that H is 2 centimeters, and I want you to figure out what the point for the left lower point, the first point of the block on the bottom, the second point of the block on the bottom, and then the end point to the wall, which is 20H away from the second point on the block. So I want you to figure out the first 6 points and their coordinate numbers. And I'm going to pause this so I can do the same. Okay, so hopefully you have the points. I have the points specified in my Genie document here. And what we have is what I got, and that's 0, 18. First point rather is 0, 0, 0. The second point, and this is point 2, this would be point 0. So don't label this point 0. Put a 0 down here at the bottom next to the corner, and then put comma because we're going to put another number. And the right is in front and the left is in back. So the left is going to be 0.0 is going to be the back wall, part of the back wall. So put a point 0 right here, and then point 1 is 18, 0, 0, and then H is 2, so point 2 is 20, 0, 0. Point 3 is going to be another box. Let's go ahead and go down to the mesh setup. Point 3 is going to be right here, and that is going to be 22, 0, 0, because this is H, and this is a square, and that's H. And then point 4, so it's 0, 1, 2, 3, 4. So it goes 0, 1, 2, 3, 4. And point 4 is going to be 22. 24, well, it's point 3 over here because it starts out as 0. So it starts out as 0, 1, 2, 3. So point 3 is 22, 0, 0. Point 4 is 24 because this is H, 24, 0, 0. And point 6 is 62, 0, 0. And then, so we have that. And our, if I used 2 if functions here before, I want to explain this a little bit. I didn't explain it last time because when I was using if, else if, and else, I was getting an error. But I've discovered since then that I can use else if and not get the same error. So I'm going to try to be more accurate. So we have here 6 points. And we know that SY is equal to 6 points. The total points that we're going to be done with after we're finished with this is going to be 6, 12, 18, 24. So the total points that we're going to have is 24. And so this SY is 6. So we know we're going to have 24. So let's say 4 times SY is 24, and then we know it's going to be 4 times SY here, which is 24, and SY is 6. So 6 times 4 is 24, and we want the first row is going to produce the second row. So the row that we specified here through these 6 points are, which are the bottom row here, they're going to specify this second row, and then the second row is going to specify the third row, and then the third row is going to specify the fourth row. So we need an if function so that we can specify the second row, and then we need another else if to specify the third row, and then we need another else if to specify the fourth row. I'm not using else because I keep getting errors when I use else. And so we're going to be, the first one is while I is less than 5, or 6 rather, while I is less than 5, because this goes through 0 through 5, and there's a total of 6 points. 6 points, it goes from 0 to 5, as you can see here. And so when I is less than 6, we got to change this because it's not growing by that, it's growing by 2 centimeters, so it's going to be 2. And when I is equal to 0, sy is equal to 6. So this is going to be remember point all the way up to 0.5 is on the bottom. This one right here, this point is going to be 0.6. This is going to be 0.7, 8, 9, 10, and then 11 at the end. So when I over here, when I is equal to 0, sy is equal to 6. So this is going to be 6. 0.6 is going to be point x and point y plus 2. All the point x's are the same here because it's symmetric. And so the thing is we have point we're going to be adding 2 to the point y points, so that's one block. And remember, this h is 0.2, or 2 is 2 centimeters. They have it listed as 0.02 in here, but it's 2 centimeters. And I changed the block mesh to convert to centimeters, and so I can use 2 here. And I suggest you do that instead of keeping it in meters. It makes it a lot easier. And then we're going to have another if function. Just going to have to make the next one. So if I is greater than 5, so 6, and less than 12, it's going to be the point plus 2. It's going to be plus 2 again. And because it's going up by another 2, it's a square. And remember, it's a square. All these squares are of equal size to this square, so it's 2 centimeters height is change. And so it's going to be going up by 2. And when I is greater than 5, so when it's equal to 6, sy is equal to 6. So that's going to be 0.12. You remember this went from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 0.12, and we're creating this line with the second if function. And so we go back to Genie, and we say, okay, so when I is equal to 7, then it's going to be 7 plus 6, which is equal to 13. And it's going to be by 2. So this is going to create the second row. I'm going to use the else if here, if I can spell, if I is greater than 11 and I is less than 18, because we're creating and we say copy this down. And this is going to go up by 36 if you do the math according to the first diagram I showed you where it had 10H, 20H, and you figure that out and you get 20H on this side over here too. So it's H and H, so it's going to be 18H to get this. It comes out 18 times 2, which is 36 that we're going to go up. So we're going to go up by by 36 points to the final, to the top. And that's going to be when I is 11, or 12 rather, SY is equal to 6. So that's going to be 18. And point 18 is going to be up here at the top. And it's going to go point 18, 19, 20, 21, 22, 23. And we're going from 0 to 23. So that's a total of 24 points. So hopefully, so now I want you to write those numbers down. I want you to have on the left hand side, write 0 and then comma, and then sooner or later we're going to put the point for the right hand side, but the left hand side is 0 and it's the back wall. And then it's going to be 1 comma 2 comma 3 comma 4 comma 5 comma 6 comma 7 comma 8 comma 9 comma 10 comma 11 comma 12 comma 13 comma 14 comma 15 comma 16 comma and continued until you get to 23 comma up here. And what we did there is we created the first XY plane, and now we need to double it in the Z direction. So that's where we're going to go back to our block mesh dictionary. And so what we did here, we duplicated the Y points. We didn't grow, we duplicate rather. We grew the Y points, and then we're going to duplicate Z points. And we can leave this the same in order to duplicate all the Z points. But let's make sure that we have the right number. So the size is going to be now 24 because we have a total of 24 points, 0 to 23. We have a total of 24 points, so the size is going to be 24. And so this is going to be 2 times 24, which is 48, right? 2 times 24 is 48. And we're going to duplicate it in the Z direction, so all the points are going to be duplicated. So it's going to be 48 points total. And we're going to have to go from, we're going to have to go to 48 points, and we want to grow them all in the Z direction by, let's say, 0.5 centimeters, because we want that to be small. Put 0 there, 0.5, and we want 24 points to go through this. So it's going to be 4 times 6, and then this right here, we're going to do all the points. So this is going to be, let me see here. I think it's 8 times 6. I think. Let me pause this here in a second and make sure I got this correct. Okay, I was wrong. I want this to be SZ because SE is actually now it's 4 times SY, and that was 6, so that's 24, because we want to cycle through all 24 points, and we want to start out at 0. So we're going to go less than 24, which is 23. 0 to 23 is 24 points. And then that's going to duplicate the Z points in the Y direction. And then we're going to want to print out all 48 points. So SZ is 24, so it's going to be 2 times 24 down here. So we haven't done any of the hex blocks or the faces, but that's what your geometry that you created here and the numbers are going to be used for. But right now we want to see if we can actually run the actual see if we can run block mesh. First let's foam clean tutorials, and it should be fine because it was just clone, but good habits. Okay, it's giving us all kinds of errors about block hacks and everything else. Okay, so here's our points. Let's check these and see if a couple of them are correct. We know this is supposed to be 0, and when 0 is over here, when the SZ is 24, when I equals 0, SZ equals 24. So you have 0, 24. I want you to put that down. 0, 24. And then I want you to go through and I want you to do the same thing for all the other points. And here's the list of points. I'm going to pause this. I want you to go ahead and now use this list of points to go ahead and write in the points for all of the for all the geometry. And like this is going to be 0, 24. This is going to be 1 and 25. This is going to be 2 and 26. This is going to be 3 and 27. And this is going to be 4 and 28. And this is going to be 5 and 29. This is going to be 6 and 30. And then on and on and on and on. So I'm going to go ahead and pause this and let you go ahead and take care of that. Okay, look at your geometry. And the geometry is going to look something like this. And I want you to, this point right here is going to be 0, 24. And this point right up here is going to be 23, 47. This point right here on the top left is going to be 1842, and the bottom right is going to be 5, 29. And all the other points should fit in between there, going from left to right and getting larger, sequentially larger. I don't want to go through all the points right now, but I can, and I might as well. It's going to take a little time, but I think that you'll have the time so you understand. This is 0, 24. This is 125. This is 226. This is 327. This is 428. This is 529. This is 630. This is 731. 832. 933. 1034. 1135. And then this is 1236. 1337. 1438. 1539, 1640 right here, and this is 1741, 1842, this is 1943, this is 2044, this is 2145, this is 2246, and this point is 2347. So we've done that, and we know that our points, I checked them, and my points match correctly. So I know that I have the right points. So now it's time to use the geometry and to figure out what the hex values are going to be, and what the and I'm gonna pause this. I want you to create a piece of paper, and I want you to write up the top blocks, and then I want you to put 1 through 14, because there's going to be 14 total blocks, and I want you to put top wall, bottom wall, put space, couple lines, bottom wall, couple lines, box, a couple lines, inlet, a couple lines, outlet, and then maybe on the front or back, front and back walls, and then back, underline, and multiple spaces, probably about 6 spaces, 6 lines, and then front and about 6 lines because it takes up a lot. We're going to be specifying a lot of faces and a lot of blocks. So we need to have the paper that I suggested that you actually create in order to do that, because my tutorials include the actual person as a participant. So not all of them, but some of them. And I'm not saying it's any better than anybody else. It's just the way I like to do it, because I try to be active. And so I'm gonna pause this and give you a little time to take care of that. Okay, so let's bring up if you look at your piece of paper, then it's split up in sections like this. For block 1, and this is block 1, remember the blocks here don't correspond to what block numbers you have on your paper. Here block 1 is equal to block 1, and we know the points because if you look at your piece of paper, you got your points, and the hex block for block 1 is 0, 1, 7, 6, 24, 25, 31, 30. So let me go ahead and I'm going to go ahead and enter in all the hex blocks, and then I'm going to pause this, enter in all hex blocks, and then okay, so here's my hex blocks. I'm not going to, because there's so many of them, I'm not going to call out every one of them, but the first block is 0, 1, 7, 6, 24, 25, 31, and 30. I like to try start out from the small numbers and then grow to the bigger number. And the way you do that is you have 0 and 24 here, you have 1 and 25 here, and you have 6 and 30 here, and you have 7 and 31 here. And we don't have to draw another block. We could just go counterclockwise. What you're supposed to do, since 0 is on the back, you're supposed to turn this geometry and turn the 0.0 towards you and closest to you, and then go in a clockwise direction. But you can look at 0 in the back wall without turning it towards you and realize that counterclockwise is clockwise when you turn it. Counterclockwise without turning it is the same as clockwise when you turn it. So we want to go clockwise. So now we're going to leave it the same as what it is on the paper, just like here, and we're going to go 0, because we're going to go counterclockwise, 1, and then 7, 6, 0, 1, 7, 6, 0, 1, 7, 6, and then 24, 25, 31, 30. And that's block 1. And as you can see, that comes out, that's how I got this. And then we're going to go grading with X and Y of 10 each time. Just do 10 each time for X and Y, and do simple grading in 1. So I want you to look at your blocks and see what you got. And I want you to compare them to my blocks, because to be honest with you, I know that these work. So I want you to compare my blocks and see if what you got is the same as what I got. Alright, so I hope that you have the same hex blocks that I have. And now we're going to change this because we have an inlet. because we're going to be flowing air in over the square. So we have an inlet, and we're going to call that type patch. And the inlet has three, it has this, and this. So it has this face, and this face on the geometry. So inlet has three. So we're going to go with inlet, and then the first one is, if you look at this first face, then the numbers are 12, 36 for this one, and this one up here is 1842. So 12 is in the back. Remember, left is back, right is front. So we want to go clockwise. We want to look the inside towards the outside, and then we want to go clockwise. And this one right here is 12 and 26, and this one right here is 18 and 42. So if we go clockwise, we're going to go from 12 to 36, 26 rather, and then 42, 18. 12, 26, 42, 18. Or actually, that should be 36. 12, 36. I had it written, almost looked like a 20. 12, 12, 36, 42, 18. Should be that face, because we're looking from the inside out, and 12 is left, that's the back. 36 is right, that's the front. 18 is left, that's the back. 42 is right, that's the front. If you're looking inside out, the 36 and 42 are closest to you. The 12 and 18 are the farthest away from you, and we're going to go in the clockwise direction. So we're going to go from the smallest number, which is 12, to the next number in the clockwise direction, which is 36, to 42 to 18. And then this face right here is made up of from 6 and 30 to 12 and 36. So 6 is in the back, 12 is in the back, 30 is in the front, 36 in the front. So clockwise, we're looking on the inside out. So clockwise is going to be 6, 30, 36, 12. And that's going to be inlet. And then this face right here is 0, 24. 0 is left. That means back. 24 is right. That means front. 6, 30. 6 is back. 30 is front. And so we're going to go clockwise, and that's going to be 0, 24, 36. And that's inlet. And I know these worked because of the method I used. I actually got it pretty quick. Had a couple errors, a couple of them wrong, inputs wrong, but I actually put them in. So let me go ahead and type it in here for me. 12. I'll pause this and I'll come back. Okay, I've entered mine in. So now we're going to go to the fixed walls. And I'm going to go ahead and enter all these in. But the fixed walls are going to be the bottom wall, and which is made up of this face, this face, this face, this face, and this face. And then you're going to have the right wall, which is which is these faces. This is the outlet. This is going to be called the outlet. And then so the fixed walls are going to be the bottom wall and the top wall. Top wall is not moving here like cavity, so the bottom wall and top wall are fixed. The left side is inlet and the right side is outlet. And the only other places that we're going to have walls around box, but I'm going to show you how to specify a round box so that you don't have to, so that you get the walls where you want them and you don't have to worry about inlet, outlet. Or inverted rather. You don't have to worry about inverted, not inlet, outlet, but inverted. So I'm gonna go ahead and pause this, and I'm gonna enter in all my numbers. Okay, so I've entered all mine in. So now I want you to go through, and I'm going to slowly move these down. You're going to have to go back and pause. You can pause here. You can pause here. You can pause here. And you can pause here and verify your numbers. So I'm going to pause and let you do that. Okay. Let's open up Genie. So I said that this should work. Hopefully it will. And if it's not, I'll have to figure out what's going on. But let's go ahead and do a foam clean tutorials. Foam clean poly mesh. And let's try block mesh. And I got an error. So let me go ahead and figure out what this error is. So we got block hex 01439101312 has inward pointing points, and it says which ones they are. So let me go ahead and pause this and figure out which one it is. Okay, here's the actual number, so let's go through that once again. But before we do, so you're not wasting your time, I couldn't find my error, so I copied and pasted what I had done before in. So I'm gonna let you compare your numbers to these, but I want to show you that this works. I've already done the so you can see that this works. So let's go ahead and look at the blocks. So you can see it actually works and it creates geometry. So instead of looking for all of it and going through it, I was just like, well, I'm in a hurry. So I just copied and pasted what I had before, which was over here in this block mesh dictionary file. So I copy and paste that over here. But anyway, so here's the actual blocks, hex blocks. So you can pause here. Pause here. This is the boundary inlet to top walls. Pause here. This is bottom walls to front and back, sum of front and back. Then you can pause here with front and back and check those, and then you'll have the correct ones. But as you can see, that it was actually the working solution actually worked. And if we foam clean tutorials, foam clean poly mesh, do a block mesh, take a look at the mesh, and I didn't actually optimize the mesh. It's something I'll let you do, but I'll tell you, if you read the article that I supply in the information section under the video, then they do 80 mesh. Oh, the reason why, what we just got a fatal error, and you can see here it says at line 180, but it says cannot find patch field entry for inlet, and that's because we didn't change our P file and U file of point field small block in the O directory. So we didn't change that. We still have the old P, which is moving wall, fixed walls. So we don't want that. What we want is we want to change those to P original and U original like we have here. Because it's looking for information here. It doesn't need these files to do the mesh, but it's looking for information to make sure that they match up. So let me pause this and we'll change these. As you can see, I'm in point field and then small block. I changed them to P original and U original. So they've been changed. So let's go ahead and try to run this again. Do foam clean tutorials. Foam clean polymesh. And then parafoam, or block mesh rather. And now I'll actually run the mesh. Because when we tried to look at the mesh before, it was trying to correlate it to P and 0 for some odd reason, but you don't need those files to look at the mesh. Need those files to look at mesh, and let's do a parafoam. And you can see you can set up a nice mesh. You'll have the opportunity to do that. But this is our geometry, and we're going to change to solid color and surface with edges, and this is what the mesh looks like. So if you actually adjust this and put 80, make sure you have 80 blocks per H, 80 per H, but in this direction here, it's got to be a one-to-one relationship, so this has got to be 80 per H2 in this direction for this area right here. And these are going to be 80 per H, but then you can do a gradient from this area all the way up to this area. You can do a gradient. And that's what you need to do. And I suggest that you read the document that we looked at from the beginning, which is this document right here, and follow through with it. And then you'll actually have something to compare it to. Well, I guess there's no 0. It's not C++. But anyway, so that's the end of this tutorial. I'm sorry I didn't work through the problem error with you. It's just I'm in a little hurry today. But you have a nice day, and I hope you enjoyed this tutorial.